Okay, this is an updated version of in the future. Alright, I've come from the future, and I believe some informations must be informed to you here. Actually, this whole video will talk about with regards to the factor of safety actually. Alright, so the first thing is actually the TSAI theory, where although you would want your material, this thing is the calculation for your factor of safety. You want your factor of safety to be lower than 1. If anything higher than 1, which is this case, you'll be your material will fail. Okay, so therefore in order to calculate your factors of safety is not that easy, alright, because this is not the full equation yet. Alright, the full equation includes 1 over f squared. Alright, it should be this equation, and this is not given to you, and therefore you need to take note of it. Okay, and this is it for the TSAI theory. Next up is the max stress theory. The theory for all this is for longitudinal, shear, and transverse, right? Is what we have discussed. But there is a special case where I don't even know what the special case is talking about. Alright, he says that when theta is equals to 0. Oh, I know why. Okay, so this can be extended. Alright, so what I mean is that in order to find your factor of safety, this is not the final equation. Alright, the final thing is that you have your factor of safety is equals to x divided by cosine square theta multiplied by sigma theta. Okay, so it's gonna multiply with this thing, and yeah lor. You need to take note that this stress, alright, is not the when you're calculating this is not equals to this. This is the applied stress, this is the applied stress, this is also the applied stress, this is also the applied stress. So it's a factor, or is a ratio between the strength of the material divided by the applied stress. I repeat again, it's the strength of the material divided by the applied stress. And therefore, if happen that your theta is equals to 0 degrees, alright, which means that cosine 0 is 1, right? So you have the factor of safety as equals to x times sigma theta, or in other words, sigma 1 in the one direction, because you're pulling in the one direction, right? So this is the first equation that you're going to come about. And if your theta is equals to 45 degrees, which is the shear one, alright, sine 45 and cosine 45, you'll give yourself 1. You can type into the calculator and see. No, when I type into calculator, it's not. It's 0.7 something. Cosine theta is also 0.7 something. I mean cosine 45. So eventually you will know that your f is equals to s times this thing over here is actually 0.5. Alright, so therefore it's 0.5 multiplied by your sigma theta. Alright, this is the shear stress. So shear stress, instead of sigma theta, we should call it as a shearing 1, 2. Alright, later on in the later part of the tutorials we'll talk about it. But this is the thing. But in the end, in the tutorial, we actually didn't use this. I also don't know why. It's pretty complicated, really, seriously. I also don't know what the hell is going on. But in the end, you will know that the stress 1, 2 is actually 2 times stress 1, 2. Alright, this thing over here, alright, is equals to 2 times shear stress 1, 2, which is for this case only lah, if it's a theta equals to 45 degrees. So therefore is 2 times this thing, and the 2 and the 0.5 cancel out, you will have s 1, 2. Okay, and this is how you calculate for a factor of safety if you have an angle of 45 degrees. Alright, for your shearing. And likewise for your if it's a 90 degrees, alright, sine 90 is actually equals to 1. Alright, so sigma theta, I should say that the factor is equals to y divided by sine square theta times sigma theta, which is, this is actually sigma 2. Alright, y is in the, in fact the diagram also draw, he placed wrongly. It should be in this direction. Yeah, that is better. If not, I find it very 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 super weird. This is in the y direction, alright, in the y direction. So therefore, yeah lor. So this is equals to 1, and therefore f is equals to y divided by sigma 2. Alright. So therefore, these are the special cases. If theta is equals to 0 degrees, you can calculate for a factor of safety over here. For shearing 45 degrees and your transverse is 90 degrees, you get this. Alright. Other than these three angles, if you have other angles, then you're gonna use this formula. And then once you use this formula already, you ensure that your this value, for example, this is 5, and if your this value is actually 2, so the factor of safety is actually 5 divided by 2. Alright, so you're going to bring this 2 downwards. Alright, this is how you calculate your factor of safety, and which we didn't actually go through it properly in the previous part of the videos. So after thinking about it, I think this is a more better way to illustrate to you the concept of finding the factor of safety. Alright, so I think this is it then. Yeah.